yesterday we discussed up to, I think, characteristic X-ray spectrum. Okay, and mm, in that characteristic X-ray spectrum, what I said actually, uh, when electron here knocks out the orbiting electron, then immediately the difference in the energies of different orbits results to one kind of line spectrum that is called as characteristic spectrum. This is what I said yesterday. Suppose here, uh, if I take, if I assume one electron is knocked out from the first orbit, means ground state, that is k orbit. Okay, then immediately there are the different chances here. Then the electron may jump from next second orbit or third orbit or fourth orbit or the higher orbits. From any orbit, the electron can jump to the k orbit, means first orbit. Why? Because electron is knocked out from the k orbit. Okay, the striking electron knocks out one electron from k orbit, orbiting electron in the first orbit, and this is what the striking electron knocks out. Suppose here, right? This is one electron, striking electron, and it is the orbiting electron. Then obviously here the k orbit becomes empty. Then from higher orbits, the electrons will jump. Suppose when electron jumps from second orbit, okay, then you name the second orbit as L orbit, L orbit. Okay, like I'm giving the names here, L, M, N, and so on. Okay, electron jumps from L orbit to K orbit. Then the energy difference that all of you know, and the wavelength also you know, 1 by lambda is equals to, you will get something here. Okay, that is r into, according to Bohr's theory, 1 by n1 square minus 1 by n2 square into z square. Okay, given by Bohr. Okay, this is the Bohr's equation. Scientist Bohr. So from this we can say here, we can put n1 is equals to 1, n2 is equals to 2, and you can find out what is the wavelength coming out of this transition energy. Okay, and here when an electron jumps from m to k and then n to k and so on, if you see there, you can easily understand here. Compared to this energy difference, the energy difference when electron jumps from higher orbits will be increased. Okay, here energy difference will be more. That's why energy difference is increasing when an electron jumps from higher and then highest orbits. Okay, uh, the energy difference is more, means wavelength will be decreased. Okay, that's why suppose if I give the name, the wavelength whatever you are getting during this transition, that is L to K. Okay, That wavelength I take it as K alpha. Okay. Why? Because this is coming due to the knocking of the electron from K orbit. That's whatever the wavelength I'm getting, okay, is K alpha. First line. Second line, K beta. Third line, K gamma, and so on. I give the names like, okay. Here you can say that energy of K alpha line is less than energy of K beta line in spectrum. No, what I'm saying is less than energy of K gamma line. Okay, better I write here neatly. This is K beta. Okay. So energy is increased, okay, when going to higher order. Wavelength will be here, energy is less, so wavelength will be maximum. So I write lambda of K alpha line is greater than lambda of K beta line is greater than lambda of K gamma line, and greater than so on. Here less than so on I can write. Okay. So here, if you see these type of lens, where you get such characteristic wavelengths, particular wavelength this is, okay, that they may ask in exam, Nana, in the same spectrum. So when you turn to objective here, what type of question they ask in objective? Same like in the previous class, what I explained, the intensity wavelength graph. Okay, I'm taking here. And as usual, first I am drawing the characteristic spectrum, sorry, continuous spectrum. This is common. Yesterday only I told. Okay. It starts from lambda minimum. How to find that lambda minimum also, I gave one formula for you all. And here, these characteristic wavelengths, suppose in the graph, he mentions those lines as some peaks like this, like some peaks. Suppose if he mentions like this, then they ask in exam, these are one particular wavelengths. Nana. Those particular wavelengths he represented like peaks. This is one particular wavelength. That's why represented with a different color. That is characteristic, one particular wavelength. And here also this is one particular wavelength. And it is also one particular wavelength. Okay. Here, if you see these wavelengths, particular wavelengths, characteristic wavelengths, okay, then they may ask by representing line 1, 2, 3. 1 stands for which wavelength, the second 2 stands for which other wavelength, 3 stands for which is the third wavelength. Okay, to say that you require this equation. So if you see here, lambda of K alpha is more in the representation, means I have to say higher of the 3 wavelengths what he gave in exam. Okay, I surely say this is lambda of K alpha. Okay, so here I'm going back like lambda of K beta here, and this is lambda of K gamma here. Sorry, K gamma. The third one is, this is lambda of K gamma. Okay, so like you can say, okay, so here you can observe that alpha, beta, gamma will come in reverse order. Okay, this is one story. And one time, actually this was not given in exam, he mentioned one is K, other is L. L means electron should jump from where to where. This is actually, we call it as first one. These are all K series wavelengths. Or simply grammatically, if you see here, better we write like this. These are all the wavelengths of K series in characteristic spectrum. Okay. These are wavelengths what we got only when an electron is knocked out from K orbit. But who knows it knocks out only from K orbit? So there is a possibility of knocking out the electron from L orbit in the same way M orbit or in the same way N orbit. All possibilities we have to discuss. So second possibility, if the electron is knocked out from L orbit, okay, this is like Lyman series. Next we are going to discuss like in the hydrogen spectrum, the L series. L series means Bohrs series we are going to discuss, particularly in a hydrogen atom. Okay, since it is not a hydrogen atom, we should not call them as Lyman series, Bohrs series, Paschen series, blah blah blah. Okay, that's why we are giving different names here. Instead of Lyman series, I called it as K series. Okay, so I think you understood here. And then in this case, suppose if I draw one more line here, K, L, M, N, and O. Suppose this is one more line I took. Then you can see here, this is K, L, M, N, and O. You can understand that electron jumps from, there is a first possibility, M to L. Okay. Second possibility, N to L. Third possibility, O to L, and so on. You can find out many wavelengths. And in the same way, no need to explain. Similarly, you can say these two conclusions. Okay. This one, as usual, I say M to N means 3 to 2. I call it as in the same way L alpha. In the same way, this is L beta and this is L gamma, and so on I will get. Okay. And here, finally, I am not writing this stuff, you understood. And I'm going to the wavelengths. Here I write in the same way. Lambda of L alpha is greater than lambda of L beta is greater than lambda of L gamma. This one easily you can understand, and so on. Similarly, you can write. But when you come to exam, particularly advanced in related to X-rays, they ask questions in advanced manner compared to mains. This one is important to for advance. That doesn't mean they won't ask any questions in mains. They may ask, but compared to mains, it is very important in advance. Okay, X-rays concept. When you come to objective type of exams. So if you come to here, in advance, what type of questions they ask? Whether the lambda of L alpha is greater than K alpha or not. They ask such a type of questions now. Means one particular wavelength related to another series. Not in the same series. In the same series, we easily say whose wavelength is more. Okay, so they link with another series. Link with another series means that wavelength mainly depends upon whom we have to check from here. Okay, like 1 by n1 square minus 1 by n2 square. So here, that one to check here, I write as we know, 1 by lambda is directly proportional to 1 by n1 square minus 1 by n2 square. Okay, I can write here 1 by lambda is equals to some constant into, this is for example, if I write K alpha, I write that is from 2 to 1. 2 to 1 means 1 by 1 square minus 1 by 2 square. This is what I am saying. You have to check. Okay, so you are getting right, like K lambda of K alpha is equals to, you are getting, I think 4 minus 1 3, 4 by 3 into some constant. Okay, 1 by constant, some other constant you will get after reciprocal. Okay, you will get like this. And in the same way, here lambda of k beta, you can write 1 by 1 square minus 1 by 3 square, 3 to 12. 1 by 3 square means 9. You will get 9 by 8 into some constant. I think you are following here. This is transition of 2 to 1, and this is the transition of 3 to 1. That's why 1 by 1 square minus 1 by 3 square we write. Okay, and here the lambda of the third line k gamma, if you want to write to compare, I'm writing everything here now. So that is 4 to 1. 4 to 1 is lambda of k gamma line. I'm writing k gamma is 4 to 1. That is 1 minus 1 by 16. After reciprocating, I will get 16 by 15 into constant. I will get some constant here. Okay, into constant. Okay, now this is of what? Only k series now. We interlinked like this. But what he asked here, one wavelength of a particular series linked with the wavelength of another series. So lambda of L alpha I'm going to write. Keep in mind that is from 3 to 2. Okay, 3 to 2 means here what we write. Lambda of L alpha. You can understand that that is equals to 3 to 2 means 1 by 2 square minus 1 by 3 square. Okay, just for checking here I'm writing 1 by 2 square minus 1 by 3 square means you will get 9 fours are 16, sorry, 9 fours are 36, by 9 minus 4 is 5 into constant you will get. Okay, if I'm not wrong. Okay, I think you are also checking there along with me. This is 3 by 3 to 2 means 1 by 4, 1 by 9, 1 by 4 minus 1 by 9, 9 fours are 36, 36 minus 4, sorry, 30 36, 9 minus 4, 5, correct only. Okay, right. And then from 4 to 2, if you check here, this is lambda of L beta line. Okay, this is equals to how much we get. 4 to 2 means here I have to take 4 square. 16 and 4. 16 and 4 means 16 is the LCM. Here I can write 4 fours are minus 1. That is 16 by 3 into constant. Okay. And third one, what we are checking here, 5 to 2. This is lambda of L gamma. That is equals to 1 by 5 square means I will get 25, 25 fours are 100. So here I will get 25 minus 4, that I am getting 100 by 21 into constant. Now you can say whose wavelength, what he asked, lambda of k alpha is greater or lambda of L alpha is greater. Now you can check and say the answer here. Okay, so come to there. We are coming to here. What happened? Yeah, it is not responding. Something happened to it. Yeah, it is what. So coming to here, this is 36 by 5 nana. You can say 36 by 5 is obviously more than 4 by 3. 4 by 3 means 1.33. Okay, are you following? Am I right, Nana? Right. Here 5 sevens are. This is 7 point and this is 1 point. So you can understand that here, if they give 3 wavelengths, like we can say from the above explanation, we can say that here what k of k series alpha wavelength is less than L alpha. In the same way, next series, this is of what, Nana? L series. This is L series. In the same way, M series, N series, O series, like we will get. So we can say alpha line wavelength is minimum for k, and then followed by, we can say that lambda of k alpha is less than lambda of L alpha. Only alpha lines we are checking here. I think there is no confusion. Okay. Previously we checked a particular series. Now we are checking a particular line. Alpha line I'm checking. Alpha line in K series, alpha line in L series, alpha line in M series, and so on. Like that I'm checking. So E is less than lambda of M alpha is less than, so on. You can write. Okay. Similarly, we can write the other lines also. We can write the comparison for the other lines. Why? Because same k beta of k beta is less than L beta is less than M beta is less than. For beta line also you can write. For gamma line also you can write, so on. The comparison for the other specific lines. Okay, alpha line or beta line or gamma line, like that you can write. That is the meaning of here other specific line. Okay, so here can you compare, like suppose k alpha is given, L alpha is given, L beta is given. Can you compare L alpha, L beta with k alpha? Okay, that is what he is asking. So no need to check their values. K alpha means simple, some constant 1 by lambda, what I'm saying. That is some constant into, you can write 1 by 1 square minus 1 by 2 square. Okay. And here L alpha line you can write like 1 by 2 square minus 1 by 3 square into same constant you will get here. 1 by lambda of L alpha. In the same 1 by lambda of L beta you can write here 1 by 2 square minus 1 by 4 square. Okay. If I add actually or subtract these two lines, what will I get? And that can you compare with the K alpha? I say surely not. Why? Because this one 1 by 1 square minus 1 by 2 square. 1 by 1 square minus 1 by 2 square I am not getting here. Okay. So what you are getting, sir? Just suppose if I subtract these two lines, means 1 by lambda of L alpha minus 1 by lambda of L beta. Okay, better I take L beta minus L alpha. Then you can write here, you will get same constant into 1 by 3 square minus 1 by 4 square. Okay, means this is not at all related to K series. Directly you can say this is related to 3, 4 successive, 4 to 3. 4 to 3 means L, K, L, M, M series. M alpha you are actually getting. I think you are following my logic. In the same way, in exam, he asked here K alpha, K beta given, how to interrelate with the L series. Okay, so here, suppose 1 by lambda of K alpha, that is constant, into 1 by 1 square minus 1 by 2 square, and 1 by lambda of K beta is nothing but constant into 1 by, in the same way, 1 square minus 1 by 3 square. Like in the previous explanation, you can say that 1 by lambda of k beta minus 1 by lambda of k alpha, you are getting by subtracting these two, you will get some same constant into 1 by 2 square minus 1 by 3 square. This one straight away I am writing it as what second orbit, third orbit, successive orbits. So this is lambda of second one L series 3 to 2 alpha line. So 1 by lambda of k beta is equals to, I am writing 1 by lambda of L alpha plus 1 by lambda of k alpha. This was the question previously given. How to interlate the wavelengths of different series. Okay. This type of question was given in Excel. And you can find such type of question in all books also. Okay. This was given. Okay. Then you may ask here, sir, why you are writing the full form? You are not writing here the full form of Bohrs equation, what he gave, like r into z square. Why you are avoiding here in writing that r into z square? Instead of that, every time I am watching from the first page, sir, you are writing into some constant, you are writing. Even in the previous IIT question also, you said like writing some constant interrelated the wavelengths. Why you are avoiding here in writing r and z? Means you did not like the Bohrs equation, sir? No, not like that. This one, the same equation, what I said yesterday, concluded that equation was practically checked by the scientist Mosley. So here I am coming to Mosley's uh, results. Okay, what he said. He conducted the experiment. Okay, experiment means yesterday what I told, some discharge tube inside, like some high melting point target we took there, and electron strikes with the accelerating voltage and emits the X-rays, here unknown rays they found. That experiment, he conducted the experiment with different targets. Actually, we take molybdenum or tungsten. Why? Because when electron strikes, it releases lot of energy. By absorbing that energy, suppose the metal melts, then the total experiment will be failed. That's why we conducted here yesterday. Here we means the Ronjan conducted, not you and I. The Ronjan conducted with the molybdenum and that what tungsten. But he mostly changed that target and tried to cool every time by keeping that target like at low temperature, like it is connected to a metal rod and wound with circulating water. Means wound with a pipe and continuously circulating the water to cool this material. So he did those, he took those precautions there. Okay, and then without melting that target, he conducted that experiment with different elements, Nana. Not only molybdenum, tungsten, different elements. Okay, by that what he observed. Okay, that's what we are checking here, different elements, and drawn a graph between the atomic number z and root nu frequency. Okay, under root frequency. There he found one graph like this. Okay, he took like, he got a graph like a straight line intersecting the x-axis like this. Okay, sir, what he took on the x-axis, sir? He took the atomic number on x-axis. Okay, and here this is the root nu what you took, and here that nu doesn't mean it is 0, means he got for different elements, like here this is root nu for one particular, this is root nu for some other particular z, and this is the root nu for some other z. Okay, like that. Means z here is not started from origin. You try to understand. Okay, x coordinate is not started from 0. Sorry, not started from 0. That's what I'm saying. Okay, root nu also not started from 0. Okay, right. And you are finding out here some intercept, x intercept, and you are finding out some slope here, and he found this is a straight line, Anna. So you can say that root nu is directly proportional to z, but not like mx. Okay, some slope, he took it as a into x intercept, so z minus b he took. Okay, this was the equation proposed by the Bohr. Okay, by this what can we say? Nu is equals to a square into z minus b whole square. That implies we can say c by lambda equals to a square into z minus b whole square. Keep in mind a and b to b is the x intercept. Okay, that implies 1 by lambda is equals to a square by c into z minus b whole square. Now he got a new equation for the wave number. It is appeared to be little bit different from the equation given by Bohr. Okay, this is wave number nu bar. Okay, there actually you got some constant like r into 1 by n1 square minus 1 by n2 square, some that whole thing here appeared like a square by c, and into he got actually z square, but mostly practically he found it is not z square, z minus b whole square. This was the modification made by Mosley. Okay, because of this small error, Bohr failed there to explain the theory properly. What failed there in explaining for other elements, only explained there valid for um, hydrogen and hydrogen like atoms. Because of this small error, actually that equation is not for z, is not z square, z minus b whole square. Since there is some error here in place of z, I was here not interested to put that r into z square in all equations. Okay, X-ray actually this spectrum particularly led a great revolution here, giving one new equation for the characteristic wavelength, which was given by Bohr. Okay, this is the equation was given by Bohr, and in that equation, mostly found what is the flaw, the error in the equation. Okay, by this you can say that who is a square by c sir? Again, by comparing with that equation, you can say here in this page, I can say sir, a square by c is nothing but there I write okay, where a square by c is nothing but according to Bohr's equation, r into 1 by n1 square minus 1 by n2 square. Okay, that implies I can write a is equals to cr. Okay, h is missed in the middle now, cr that come in energy into 1 by n1 square minus 1 by n2 square. This is again important for your advanced exam. Okay, wise, of course I forgot, I think under root here, sorry, this is a square actually, under root of cr into 1 by n1 square minus 1 by n2 square. Okay, Where a, if you see here, that a in the equation root nu and into is equal to a into z minus b in the graph, I can say here the slope is nothing but a. Okay, az minus ab. So straight away you can say this ab is nothing but what the ab is y intercept. Sorry, b is nothing but x intercept. This is b. I think all of you understood. B is the x-intercept. Okay, and AB is the y negative y-intercept here. Whatever you get, that is negative intercept. Okay, am I right, Nana? Okay, good. So this intercept he found changes from series to series. Okay, and you can say that from this. Oh, sorry. From this A, it is depending upon, mainly of course C and R constant, depending upon not only in a series one particular line to line in any series, the slope will be changed. Why? Because N1 changes, N1 though constant, that's what I'm saying. For a particular series, even though N1 is constant, N2 changes, so line to line it will be different. Okay, so here if I ask one type of question related to objective, here by taking the graph again like this, and here I take two lines from here and same point, one more there, like this. These two graphs represent, suppose for K series, then first line is, suppose this is the first line and it is the second line, what I drew means more slope for second line, less slope for first line. So here I can say this is drawn from root nu and z gamma. One example. Okay, if I give, I can say that slope of 1 is greater than, sorry, slope of 1 is less than slope of 2. Slope means actually a. So a1 is less than a2. I can say that. Okay. So here in this, a1 is less than a2 means a value mainly depends upon 1 by n1 square minus 1 by n2 square, where a is directly proportional to, I can say, root of 1 by n1 square minus 1 by n2 square. Okay, suppose particularly for alpha and beta lines in K series, if they ask which is alpha line, which other is beta line in the K series. Suppose if they ask, I can say he is asking for K series. So I write here what for K series, N1 is equal to 1, and for alpha line, and for alpha line N2 is equals to 2, and for beta line I can write N2 is equals to 3. Okay, and also for, okay, for beta line, better I write like this only. Come up for beta line, it is N2 equals to 3. So directly you can say for alpha line 1 by n1 square minus 1 by n2 square is equals to 1 by 1 minus 1 by 4. 1 minus 1 by 4, that is 3 by 4, 0.75. Whereas for beta line, you are getting what? 1 by, oh, I did not substitute the values, sorry. Here, this is 1 square minus 2 square. This is beta line 1 by 3 square, you will get here. This one I am going to get 9 minus 1, 8 by 9. So directly I can say here 3 by 4 is greater. So A of alpha line is greater than A of beta line. Okay, why? Because 1 by n1 square minus 1 by 2 square more for alpha line. So whose slope is more? Therefore, that implies I can say second one slope is more. That implies Second line represents the K series, he said, for K series, K alpha line, and first line represents K beta line in the hydrogen spectrum. This is what I said, line to line, the slope will be changed. And B x intercept, that is constant for one particular series number. Means this is K series for both the lines, B is constant. Okay, and that B value you have to remember is equals to 1 for K line, K series. Okay, it is constant for the whole series, and when series is changed, B value will be changed. Okay, and he found the second one, B is equals to nearly 7.6. Okay, for L series. Okay, B is more means the lower elements can't give the L series, what he found. Okay, means what the hydrogen, from the hydrogen spectrum, the Bohrs said, Lyman series, Balmer series, Paschen series, all those is bakwas. Okay, that is not correct, masteru. Here where Z is less, then there are chances to get only K series, not L series, he concluded. Why? Because they found B value is approximately 7.6 for the value. B is more means the graph starts from more Z. Okay, the lower Z values you won't give that particular series. I think you understood. Okay, means what I'm saying here, if I draw a graph, you can understand. This is one line by taking here. This is one line, K line, and suppose this is another line like some this. I don't compare the slopes, Nana. Even I am also not comparing whose A is more. Just casually I'm writing here, drawing the graph here. Okay, don't mind the slope, just I am focusing more on B value, not on A value. That's why okay, some two lines I drew here. Okay, this is for K, this is of L, some line, that's it. Okay, and here this is the B value, and this B value is equals to 1, what I said, and this is the B value here, which is equals to 7.6. This is what I'm saying. The graph starts from some 7.6, means the lower atomic numbers, for lower atomic numbers, you are not getting L series. You are not getting L series means how can you say Lyman Balmer series for hydrogen spectrum? Okay, that what he said here, like. Okay, so many flaws he found and corrected those one by one here. And this one he found the characteristic spectrum mainly depending upon the Z, not on mass number of element. Practically he found. Okay, so depending upon Z means give the importance to Z, not to the mass number. Correction he made. By this, the old periodic table, which was given previously by mass, by basing mass number, he changed it to modern periodic table. That periodic table only, even in our college campus, we are seeing modern periodic table based on atomic number. Based on atomic number, they arrange the elements. Okay, from Z is equals to 1 to Z is equal to something. They arrange. Okay, that's why here modern periodic table, okay, came after Moseley's. Okay, means he found that Ore Badudha is the element mainly depending upon Z Ranana, not mass. So give importance to Z, not to the mass. Okay, by that they change the modern periodic table, the periodic table. Okay, and by changing that, we found one more advantage. They found many gaps between the elements. Element to element, they found some gap, means there should be some other element existing there. So after rearranging the modern periodic table, they found many new elements. Best example, like helium. Helium, they found after the arranging the elements in the modern periodic table based on atomic number. Okay, they found many new elements. Okay, after arranging the elements in the modern periodic table. Periodic table based on atomic number. These were the corrections made by here, proposed by here Mosley. Okay, and immediately the other scientists corrected those things and generated new periodic table, and that new periodic table is mind and body, heart and soul for the inorganic chemistry. Okay, so that was the importance we are getting here from the Mosley's experiment. Okay, by this we completed the X-rays concept and atoms chapter, Nana. Okay, if you have any doubts, you can ask in the next class. And still, if you want something, you can ask on Monday. Okay, right. Bye, everyone, Nana, here.